Hey all, how are you? Hope you people are doing fantastic. See, we are with the third video on a chapter called Structure of Atom, isn't it? So in my previous video, I have covered everything about the Bohr's model of an atom. Before he gave his model, he studied something like atomic spectra. We also studied that. We got to know what was emission spectrum, what do you mean by visible spectrum, and then continuous spectrum, discontinuous spectrum, right? On the basis of this, Bohr actually said that there are various energy levels in the atom. Right? So, whenever an electron jumps from one energy level to another energy level, it can absorb the energy and it can emit the radiation. So, emitted radiation or absorbed radiation, when you take a spectrum, various types of spectrums are possible. So, all that we have covered in the last video. And today, we are going to study one of the important and very, very valid atomic model, that is quantum atomic model. Clear? Fine. So before we go for quantum atomic model, let us revise one point that a Bohr's model said. So what did a Bohr tell is, atom has a nucleus at the center, and he said there are certain circular paths. There are certain circular paths which he called it as shells. He called these circular paths as shells, right? He named them as K shell, L shell, M shell, and so on. And he told that electrons would revolve in this circular paths, right? So electrons will revolve in a circular path. It's like electron will not go out, it will not come in. It only revolves in that fixed orbits. The other word we use for a shell is orbits. Okay, orbits is the best word that you can use. So orbit is a fixed path where electron moves in that path. Clear? So this was our Bohr's model, right? Fine. And if you want to find out the exact position of an electron at a particular time, along with the position, if you want to find out the speed of an electron, so how do you do? Yeah? Take the Bohr's model. You know now that electron is moving in this fixed orbit, and I am asking you to find what? Position of an electron and speed of an electron. Yes, electron will move with certain speed, and I'm asking you to find out position and speed of an electron. So how do you find out this position, that is exact location of an electron and the speed of an electron? Electron is a very smallest particle, right? Atom itself is very small. So inside an atom, like around the nucleus, you have this electron. Electron is much, much, much smaller than the atom, I can say. So to find the position, to find the location of an electron, you must use some ultra microscope or something, right? So no, not a normal microscope, something higher than the microscope you should use. So you will focus with a certain light, and then only you can see an electron. So here light, in the sense what? It's a kind of energy that is passing in the form of waves. Light is nothing but a radiation that is moving in the form of waves, right? So imagine the electron is here. Okay, so this is a circular orbit where the electron is here, and you want to see this particular electron. Say you are seeing with some ultra super microscope where you are focusing a light, and the light contains, these are the waves, and these waves, when it reaches the electron, then you can see with your eye, right? Say imagine these waves, the moment they touch the electron, will the electron stay here? Electron is the smallest entity. So what it will do? It will deviate its path. Okay, instead of going like this in a circular way, it would deviate its path, because these are the waves that is actually disturbing, right? Say for example, you have one dust particle on your palm. Dust particle is a very smallest particle, and this particle is lightweight, right? It can flow very faster. And imagine a small a stream of wind, slow air is coming and it is reaching on your palm. Will the dust particle stay there? It will not stay there. It would move, it would deviate, it would go in some other direction, right? So the same thing happens here. When the electron is moving in a circular path, imagine it is moving in this particular circular orbits. So whenever you want to see it, because to find the position and to find the speed, you must first see it, right? So when you're seeing it from ultra microscope or something, the rays that are coming from the microscope are like it is in a waveform. The moment they'll try to hit this electron, and the electron will not stay in this position. It would try to deviate. It would try to go somewhere else, right? So that's the reason there is a person called Heisenberg. There's a person called Heisenberg. And this Heisenberg, he said that you cannot find the position and speed of an electron at a time. What did he tell? We cannot find position and speed of an electron at a time. Okay, so this is what we call Heisenberg's uncertainty principle. Anyway, that particular word is not necessary. Just try to understand the concept. So if you think that electron is going in this fixed circular orbits, then actually we have to easily find when something is moving in a fixed form, we actually we can find out its accurate location and speed normally. Okay, see here what this person is telling is we cannot find out the position and speed of an electron at a time. That means the electron is not moving in a circular orbit, isn't it? Okay, so by this particular sentence, I can clearly say that the electron is not moving in a fixed orbit. Okay, and there is another person called de Broglie. There is another person called de Broglie. And he said that, very interesting thing he said. Electron moves in the form of a wave. Electron moves in a form of wave. Okay, see here, very interesting thing. See, electron doesn't move like that in a fixed orbit. Instead of that, electron, if this is a nucleus, if here is an electron, it would move in the form of a wave. Okay, so that means I can clearly say that electron does not move in a fixed orbits, right? It is because these are the two persons. They said, one person said we cannot find the position and speed of an electron, because when we try to find the position, you need to use some higher ultra microscope where when you pass certain radiations like light towards the electron in order to locate its position, what happens? That disturbs the movement of electron, and it would deviate its direction, right? So that way, even if you want to try to find the position of an electron, it's very difficult, right? So that is what told by Heisenberg. And another person started telling that electron doesn't move like this in a particular order. Instead of that, electron would move in the form of a wave, they told. Okay, so these are the failures of Bohr, I can say. Okay, because of the invention of these two things, Bohr's model of an atom has got a limitation. It has got a drawback. Okay, so came another model of an atom, that is quantum mechanical model. Okay, so this quantum mechanical model was introduced by a person called Schrödinger. Okay, Erwin Schrödinger. He has done lot of mathematical calculations on various experiments that was conducted on an atom. Okay, and he got one equation, based on all his experiments and calculations, he has got one equation. We call it as Schrödinger's equation. We call it as Schrödinger's equation. And don't worry about what is that equation. You no need to learn that equation. It's just like, mathematical equation. Okay, and by solving the Schrödinger's equation, he got some terms. Okay, with the help of those terms, he could actually give the entire information about the electron's location. Okay, and how the electron revolves around the nucleus, where it is located, and if you take one atom, you will have many electrons, right? So how are all these electrons are moving around the nucleus? Everything he told, right? And one important thing he tells is, see, electron is not revolving in a fixed orbit, but electron revolves or electron exists. Electron is located in something called orbitals. So comes a new word for us, orbitals. Okay, see, orbit is different, orbital is different. Orbit is something the Bohr has given, right? So orbit is something that is a fixed boundary where in that particular line itself, in that boundary itself, the electron is moving. Okay, so that is what told by Bohr. Now that is not correct. It is proved by these two scientists. Okay, and here we have something called orbitals. So he says that electrons are present in orbitals, he said, are present in orbitals. So what do you mean by this orbital? Say for example, before we understand the word orbital, say this is actually a big room. The room where I am recording this video is very, very big. Okay, it has so many, like 4 big corners it has. But you know what? I'm not using all the place, right? Say if you want to locate my position, okay, you can able to see only this area, right? You can say that ma'am is only, she's moving or she's teaching or she's using only this area, right? So this is the area where you have a chance of finding me maximum, right? Most of the time, you have a chance of finding me is in this area itself. Not in that corner of a room, not in this corner of a room, right? Only in this area. Say wherever the board is there only you have maximum chances of finding me, right? Say similarly, orbital is a space around the nucleus. Okay, now there is no such things called orbits. Okay, so this is a nucleus now. This is a nucleus now, and there is a space, there is lots of space around the nucleus. Okay, empty space. So orbital is nothing but certain space around the nucleus where you have maximum chance of finding the electron. Okay, so if you want to find the electron, you can specify one particular area, one particular region around the nucleus. Say imagine you have an electron, this particular electron is moving in this particular space around the nucleus. Okay, so it is most of the time, not 100%, 90% of the time, okay, this particular electron is only moving in this particular space. This much is the space where it is used by this electron to stay or to revolve. Such a space around the nucleus where you have maximum chance of finding an electron is called orbital. Okay, see, I can stay anywhere in this room, but in which place do you find me maximum? In which place you find me most of the time? This is the place wherever board is there. Right? Similarly, okay, if you want to find a particular electron's location, there are certain regions where that electron keeps rotating maximum of time. Most of the time, 90%, this particular electron would rotate only in this particular region around the nucleus. So that space, that region where you have maximum chance of finding the electron is called orbital. Okay, so orbital is nothing but just a space around the nucleus where maximum of the time electron spends its time in that particular region, in that particular space. So that space we are calling as orbitals. Clear? So definition of orbitals is very, very important. So what is the definition? It is nothing but a space, a three-dimensional space where we have maximum chance of finding an electron. Maximum chance of finding an electron. Okay. So such a space we will call it as orbitals. Clear? That means, you will have so many electrons around the nucleus, right? So each electron will occupy a particular space. Okay, see, this space may not be occupied by some other electron. The other electron may occupy this space. The second electron, whichever is there, may occupy this space around the nucleus. The third electron may occupy this space, right? So the space where the electron is occupying, the space where the electron is spending its maximum time, the electron is revolving maximum time, so such a space we are calling it as orbitals. So the various electrons, whatever you have around the nucleus, they are situated in orbitals. So orbital is just a three-dimensional space, guys, nothing else. Okay, fine. And now this is what the idea he gave about the presence of electron. Okay, and after that, when he solved the Schrödinger equation, he got certain numbers called quantum numbers. He got certain numbers called quantum numbers. Okay, so these quantum numbers will actually determine the exact location of an electron, will actually tell about the shape of orbitals. You have so many orbitals because you would have so many electrons, right? And each electron will occupy a particular shape. It would be rotating in a particular shape, guys. If this is a nucleus, imagine you have an electron and this electron would move in this region. The same electron would come here in this region. That means if you give a particular boundary to this space, you would give something like this. That means a particular shape you can give for that spaces, right? According to the movement of electron. So electron in this space, it is moving like this. That means, see, I'm just giving one imaginary shape for the space. That means various types of orbitals can be there depending on the movement of electrons. So which electron stays in which orbital, what are the different types of orbitals, right? So all that can be determined by quantum numbers. So quantum numbers are the things which will help you to give an address of an electron. In simple words, if I have to tell, address of an electron can be located with the help of quantum numbers. It's very important to know the address of an electron because electrons are the one which participate in chemical reaction. Say for example, you have sodium, right? What is the atomic number of sodium? It is 11. That means sodium has 11 electrons. So among the 11 electrons, only few electrons will participate in chemical reaction. Okay, so if you want to know which electron participates in chemical reaction, you must know that particular electron's address. So how do you know about the address of an electron? It is with the help of quantum numbers. So in my next class, that is in the next video, let us talk everything about the so-called quantum numbers. So with this, I end my session and keep revising the concept and subscribe our channel to learn the concepts in a easiest way and in a detailed way. Thank you so much.